Welcome to this lesson. I want us to look at these questions over here. They are revision questions from KCSE examinations over the years. Looking at question number 1, we have 5 raised to power 2x minus 1 equal to 12x. Over there, we can begin to solve. So grab your pen and a piece of paper. Solve for x in 5 raised to power 2x minus 1 equal to 12 raised to power x. We begin by first decomposing this number on my left to get 5 raised to the power of 2x multiplied by 5 raised to power of negative 1 equal to 12 to the power of x. This can be written as 5 raised to the power of 2x over 5. This is equal to 12 to the power of x. There we can multiply by 5 both sides and divide by 12 raised to the power of x, such that we get 5 raised to the power of 2x divided by 12 to the power of x equal to 5. Again, we can look at this part. We have a common power to the x. That means we can write 5 to power 2 over 12 and then both numbers raised to the power of x equal to 5. Now we have our x as the unknown as the power, and I think at this point we can introduce logarithms to both sides so that we can get x logarithm of write this as 25 divided by 12 equal to logarithm of 5. And right now I think we can isolate our x to be equal to logarithm of 5 divided by logarithm of, we can write the logarithm of 25 over 12. So that one we can do it using our calculators by writing logarithm of 5 divided by logarithm of can put a bracket 25 divided by 12. So that gives us 2.193 to 4 significant figures. So notice that we first decomposed the number to 5 to power 2x multiplied by 5 to power negative 1. That takes us to this 5 raised to power negative 1 brings 5 to the denominator. We multiplied by 5 both sides and divided by 12 to the power of x, as we can see here. Then we can isolate our power x as a common power for both 5 to the power of 2x and 12. Introducing logarithm to both sides gives us x as 2.193 in 4 significant figures. Let us proceed over to question number 2. Solve for x in this equation. 4 to the power of x plus 1 equal to 32. There are good news here because we can write the two numbers to a common base of 2. Therefore we can have 2 to the power of 2, that is 4, and then we had our original power as x plus 1, that is equal to 2 to the power of 5. So on the left we have 2 to the power of 2x plus 2 equal to 2 to the power of 5. Remember, when we have a common base 2, 2, we can now equate the powers. That means 2x plus 2 equal to 5. Then subtracting 2 from both sides, so subtract 2 from here, we get 2x. Subtract 2 from 5, we get 3. That gives us x is equal to 3 divided by 2. That is when we divide both sides by 2. So the value for x in example question number 2 is 3/2. Write 4 to base 2 and 32 to base 2, and then follow over up to the last point where we find the answer. Lastly, I want us to look at question number 3. Solve for x in 9 to the power of x plus 3 to the power of 2x minus 1 equal to 53. Step number 1, I want us to take this guy over here to the right hand side. So we shall add 1 to both sides. That takes us to 9 to the power of x plus 3 to the power of 2x equal to 54. Again, on my left, these numbers over here might have a common base. Let's write 9 to base 3, so that we can write that to 3 squared, that is 9, and we had an original power x, and then we can have here 3 to the power of 2x again equal to 54. We see these as two common numbers. There are two ways to proceed from there. The first way is we can factor out 3 to the power of 2x. We can factor out 3 to the power of 2x. Inside the bracket, what do we leave? 1 plus 1 equal to 54. That brings us to 3 to the power of 2x multiplied by 2 equal to 54. So over there we can divide both sides by 2 and this side by 2. Let us proceed on this side. So these 2 cancels and this leaves 27. So we have 3 to the power of 2x equal to 27. That is 54 divided by 2. Then from there, write 27 to base 3. 3 to the power of 2x equal to 3 to the power of 3. That is index notation for 27. That takes us to, when we have the same base, then our powers must also be equal. Therefore 2x equal to 3 and x equal to 3/2 when we divide both sides by 2 by 2. So x again is 3/2. This can also be written as 1.5. That is it. It can also be written as 1.5. So those are the 3 acceptable answers for question number 3. So right at the beginning, I said that there are 2 ways to proceed from this point over here. Let us look at an alternative there. We have 3 to the power of 2x, that is common to both of these numbers. We can let 3 to the power of 2x be equal to something like y, so that we have y plus y. So y plus y, the first y represents this, and the second y there is equal to 54. That takes us to 2y equal to 54, because these two guys over here are like terms, and then one single y is 27. We have to bring back, because y was something, we said let the number 3, because now our y was 3 to the power of 2x, now equal to 27. This takes us up to this point where we now wrote 27 to base 3, and that takes us to 3 to the power of 2x equal to 3 to the power of 3, and that also implies that x is still 3/2. So there are 2 ways to do it. You either let y to be equal to 3 to the power of 2x, that is common to both of these, or you just factor out that which is common and then proceed until we get our x is 3/2. Thank you. I want you to attempt the following questions. 2 questions for you. Solve for x in this equation. A hint here is write all these numbers to a common base. The next question, I want you to simplify this number. We have fractional indices. So just handle fractional indices and then simplify this expression for us. After doing that, I want you to compare what you found with the answers we have over here. Of course, we have the first question there. You can just follow. We have some little hints pointed on my thumb on the right of the screen. Then the next question I've asked you to solve to simplify, we get the answer is 75. I've also included some hints for you there. So compare what you found in those two questions with what we have over here. Thank you for watching. Kindly subscribe to this channel and share this with your learned friends so that you'll be getting this and many more interesting videos. Thank you.